will move on to our first task. And in the first task, we have to do two things. One is check if the words are neighbor to each other, like it just differentiate from each other with just one letter or character, whatever you can say. Or and the other task is that we have to check how many times it has appeared frequency. We need to keep these things in the mind that there can be a future task. So we can do certain things right now for that also, like lowering the words so that it would be easier for us to sort them, as it can be case sensitive. So we start off with defining a class called word and defining a constructor. Self is default, and then it gets word as a parameter. So we start off with lowering the lowercase every letter, every word, and keeping the frequency 1 for now, and making an empty list for neighbors. Then some basic functions like if they are equal, if they are lesser than. The main function is if they are they neighbors. So first thing we start off with, if they are how they can be not neighbors. If their word length is different, then they can't be neighbors. So we start off with this one and return false. If not, then we start off with defining a variable and initializing it to 0 so that we can add numbers to it. And we'll see that if the letters of the word are same, are different, then we will uh, add 1 to the variable which was initialized to 0. And if they are different than each other by the count of more than 1, then return false, and so they are not neighbors. If they are, then we will just append it to our um, list, empty list, and we will increase the number of frequency from this one. We will see more later in the task. So our task 2, here we have to define a lexicon and read data into it. So we start off with defining an empty lexicon, a list, and then we will first process the data. We'll make an empty string, and we will see that okay, if the characters are in lowercase or they're in uppercase or they have uh, space, and then we will start putting the data inside the empty string, and then we will strip the string so that empty spaces, special characters like comma, parenthesis, they are all removed from it, and we'll just get the word. And then we'll move on to reading the data. We open the file and start to cleaning our data. So we will see that if the word is in the lexicon already, um, in the list already, then we don't have to put it. So how we will see if the word, existing word we have made, if it is equal to the word, right? So we will make the frequency 1 or keep adding it and then break. If the word does not exist, then we will append it to the empty lexicon, and that's how we read the data. We are giving two parameters, lexicon, the uh, empty list, and then our text file, the databases. So if we run it, that's how we store it. Then we will move on to the task 3. So here we had to implement two sorting techniques, and firstly I chose the bubble sort, and this is our function. Then we will start off with creating two variables, one is left, one is right. So one starts from start of the list and other from the back. And then for the loop, it goes from right to the left, and it keeps on decreasing 1. And after that, the other group inside, so we are using nested loop in this, and the second loop starts from left, it goes to I minus 1, right? So after that we will just compare, if the two attributes, if the current word is greater than the other word we came across. So if it's the case, then we will swap them. If they are in wrong order, we swap them, right? So then we will just call the function and print, if we can see. Yeah. So for our second sorting technique, we are using the combination of insertion and the merge sort, and we are putting a threshold so that um, the for the smaller sublist we can use insertion, and for the bigger we can use the merge. So how we will calculate, we will just deduct uh, the last um, from the first and then add 1 to it, and if it is smaller than the threshold, then it goes to insertion. If not, then we will divide by 2 and make the list into 2 sublists and send it to the merge. So we'll start off with insertion sort. So we'll start from the second element and make the second element our key element, and then we will make initiate j as previous character, previous word, and then we, as long as j is within range and lst has the smaller word than the current word, then we will swap and uh, decrease j by -1, so it can keep on going. And for the merge sort, uh, first left is the starting index of the left sublist, and last left is the ending index of the left sublist. Last right is the ending sublist from the right. So first left was the starting and last right was the ending, and last and the right sublist starts from last left plus 1, right? So this calculates the starting index of the right sublist, and this creates an uh, empty temp list, and these are just pointers, these two. And then we will loop while these elements are both in the there are elements in both the sublist, and then we will just compare then we will compare the word attribute of the two current elements, and if the left is smaller, then we will append it to the temp and move it to the left pointer forward, otherwise right pointer. And if there are some leftovers, then we will append them to the temp, and at the end we will just join the list and put it as an output. So when I'll run this, something like this comes up, and then we will just do the time proofing for both of these. So for time proofing, it takes the lambda function and make a deep copy of the lexicon bubble sort, and the average time is calculated by deducting the bubble sort time minus the copy time of the bubble, and till the n repeats. I've increased n to 10 for the better accuracy, and same we will do with the hybrid. In the task 4, we are just making a simple if else loop. If the choice is 1, then we will begin with hybrid. If it is 2, then we will begin with the sort. So let's quickly do 2 and sorting with the bubble. That's how we do. And for the neighbors, for task 5, you have to check and add the neighbors, right? So we have already discussed is neighbor function and also the insertion sort. We'll quickly go towards the add neighbors, and if the word is in the lexicon, so we will just quickly append them in the uh, list, and then we will just pass the function, and it will show up. Unfortunately, I was not able to complete task 6, so I won't be able to show that. Thank you.